Now let's talk about cationic polymerization. Let's discuss the detailed process of cationic polymerization. First of all, it occurs in the presence of strong protonic acids such as H2SO4. Now please remember that we cannot use H3BO3 here as it is not a protonic acid. So there can be a question regarding H3BO3, that is boric acid, in entrance exams, that boric acid is not a protonic acid but instead it accepts OH negative to form BOH4 negative species, so it acts as a weak monobasic Lewis acid. So in cationic polymerization, carbocation will be formed. It can occur in the presence of Lewis acids such as AlFCl3, BF3, in the presence of trace of water as initiator. Examples include isobutylene or polymerization of isobutylene. Now let's discuss about anionic polymerization. So anionic polymerization, it is generally shown by alkene monomers with electron withdrawing substituents. Alkenes having electron withdrawing substituents such as phenyl or cyanide or COR group. So it occurs in the presence of strong bases, that can be sodium amide or potassium amide or lithium ion or amidine simply. So organometallic compound such as butyl lithium act as an initiator for this process. Examples include polymerization of styrene to form polystyrene. Now please remember, there is formation of carboanion in anionic polymerization. Now greater is the stability of carboanion, more will be the anionic polymerization, as carbocations are formed during this reaction. So examples include polymerization of styrene, acrylonitrile and methyl methacrylate. This is also termed as coordination polymerization. Anionic polymerization is also termed as coordination polymerization because it occurs through intermediate formation of coordination complexes. For example, if we consider the polymerization of ethylene, it first forms coordination complex with the transition metal titanium by donating its pi electrons to form a pi complex. We very well know that polymerization of ethylene occurs in the presence of titanium tetrachloride. Now next is the cationic polymerization. Some more points of cationic polymerization. The initiation step includes the pi bond of protonation of the pi bond of monomer to form carbocation. Now propagation step includes here the pi bond of the monomer that act as a nucleophile. The next step, that is the termination step. Now we can add a base to terminate this process, to terminate this polymerization. So termination of this type of polymerization can be done either by adding a base or by addition of a nucleophile. Nucleophile can also block this type of polymerization. Now this is basically how BF3 with water forms this type of complex that can be used during the process. Now in the case of polymerization of ethene, H positive first of all attacks ethene molecule to form 1 degree carbocation, which is basically not a stable carbocation. So that is the reason that ethene generally does not undergo cationic polymerization easily. So as we have discussed that cationic polymerization is favored by electron donating groups attached on the alkene. If we attach a methyl group or oxymethyl group or a amine group, it facilitates the cationic polymerization. Now let's understand the ways to terminate cationic polymerization. There are basically three ways to terminate cationic polymerization. It can be done either by a loss of proton or reaction of a nucleophile or by chain transfer reaction with the solvent. Now as we will very well know that carbocations do rearrangement, so extent of rearrangement of carbocation that depends on the reaction temperature. Now let's discuss few more points about anionic polymerization. As we have earlier said that lithium butyl act as an initiator in this reaction. So first it forms carbocation. We have attached a cyanide group that is electron withdrawing in nature. So initiator here is basically a nucleophile. Now if we want to terminate this process, if we want to terminate anionic polymerization, then we can use chain transfer reaction with the solvent or by reaction with any impurity. For example, CO2 can terminate this reaction. But what is interesting to note here is that still if you add further reagent, the process can restart itself. So that's why they are sometimes termed as living polymers. Superglue is an example of this type of category of polymer, which is basically methyl alpha cyanocrylate. What's interesting to note here is that the monomer contains two electron withdrawing groups. So because of the presence of these two electron withdrawing groups, a OH of cellulose or a nucleophilic group of any protein that can act as an initiator. So that is the reason it reacts with our skin very easily. So anionic polymerization that can be shown if we attach any electron withdrawing group on the alkene molecule. For example, cyanide, COH or COOR. So that is all about anionic and cationic polymerization. In the next video we will discuss about polymers and their monomers.